Now, sketching a graph of inverse trig is really just an exercise in transformation of the graph. Let me show you. Y equals 4 arc cos of x on 3. Well, the domain, so we know, sorry, let me start differently. Well, the shape of my graph is always, for an arc cos, going to look like this, okay? And arc cos has my axis like that. The challenge is figuring out how have I transformed this graph from the usual. I've stretched it vertically by 4. So normally it goes from 0 here. Maybe I'll just use this as my sketch. It'll save me worrying about grid paper and everything. So there's my origin, right? Normally I start at 0 and I finish at pi. But I'm stretching it by 4 vertically. So this point at the top, which is included, solid circle, is actually at 4 pi instead of pi as usual, which means it's crossing not at pi on 2, but at 2 pi, 4 lots of pi on 2. This point is also included. So what's these horizontal coordinates then? Well, normally it's +1 and -1. But I've got x on 3. It may help if I actually write it out for you. The domain is normally 0. Here it's x on 3. The domain of my arc cos is less or equals, no, it's not 0, it's -1. Sorry, the domain, might actually help if I write the word domain, right? Is normally -1 up to 1. The range is 0, normally pi, so now 4 pi. The domain is -1 to 1, but that's the domain of x on 3. So x then is going from -3 to 3. So it's exactly the same as when I was drawing a normal trig graph. If I multiply by a number here, I actually shrink the graph. If I divide by a number here, I actually stretch the graph out. So this point here is actually 3, 0. And this point up here is actually -3, 4 pi. And that's a perfectly fine sketch of 4 arc cos x on 3. So let's draw another. Make sure you can see what I'm writing. Y equals -3 tan to the -1 of x minus 1. So the tan graph, remember, is normally like that, going from pi on 2 to -pi on 2, 0 in the middle, etc. I didn't do a very good job of that sketch, did I? Not really. So how is this graph that I'm doing now going to be different? Well, it's stretched by 3 times vertically and it's inverted. So my graph is actually going to go the other way. Let me just do that then. My graph is actually going this way instead. It's still going to have an asymptote up here. It's still going to have the same asymptote down here. Well, except it's not quite right yet either. What else am I shifting? I've actually got a horizontal shift by 1. So this would be -3 tan to the -1 of x, right? But I've got x minus 1. Let me work out these asymptotes too. It was pi on 2. It's stretched by 3. So this is actually y equals 3 pi on 2 and y equals -3 pi on 2. Now what I'm going to do is shift this graph with a different colour. So I'm shifting it what direction? subtracting from x is going to shift it to the right. So where the original graph crossed at the origin, the new graph is actually going to cross here, 1 across. It would be helpful for me to know also the y-intercept. I actually can sketch most of the graph already. It's going to look like this. Okay? But what's my y-intercept? My y-intercept is what happens when I put x equal to 0 in here. So, for the y-intercept, set x equal to 0. Minus the y equals minus 3 tan to the negative 1 of negative 1. Alright, what's this? Well, it's going to be from a 1, 1, root 2 triangle. So, where have I got room that I can draw it that you can see? 1, 1, root 2. And this is pi on 4. So tan is 1 is pi on 4. But I need tan to be negative 1. So I'm actually looking at negative pi on 4. So it's negative 3 times negative pi on 4. And that lines up with the quick sketch I did here, because I know I should get a positive result for my y-intercept. It's 3 pi on 4. It's actually exactly halfway up to the top, so I was pretty close when I did this. 0, 3 pi on 4.